Assalamualaikum and hi, we are from Group 3 and today we are going to present a topic of polymer process. My name is Farhan Firdaus bin Abdullah and my matrix number is 229321 and I'll be the first presenter. So introduction to polymer process. Polymer process is those manufacturing process by which polymer composites are shaped into useful components and products. Many of the processes used for this material are the same or as similar to those used for plastic, and they are thermoplastic, thermoset, and elastomer type of polymer. So a different type of polymer require a different process to make it into a product. As example, to shape a thermoplastic polymer, it must be heated so that it softens to the consistency of a liquid. In this form, it is called a polymer melt. And here are some of the polymer process: compression molding, transfer molding, blow molding, extrusion molding, and injection molding. And I'm going to give a brief about this process and the rest will be covered by my team members. The first one, the injecting model molding. Injecting molding is a manufacturing process used to produce part by injecting molten material into mold. Is one of the most common method for mass producing plastic part with high precision and consistency. And some of the application is the bottle caps, automotive component, electronic housing, example of phone cases, toys like Lego bricks, and medical devices. And next, we have extrusion. So polymer extrusion is a manufacturing process used to produce continuous plastic shape, such as pipes, sheets, film, or wires, by forcing molten polymer through a shape die. So the difference of extrusion and the injecting is the extrusion is for a longer type of product. The example is plastic pipe and tubing, windows and door frames, plastic film and sheets, wire and cable coating, and straw. And lastly, we have compression molding. Compression molding is a manufacturing process used to shape thermosetting plastic or rubber by heating and pressing the material inside a mold cavity until it takes the desired shape. And some of the application is for the electrical switches and plugs, kitchenware and handles, automotive parts, and rubber gasket and seal. And next, I'll pass the presentation to my next member.
Assalamualaikum and hi. My name is Muhammad Imtiaz bin Muhammad Nasir, matrix number 227572, and I will explain about compression and transfer molding. So, first, what is compression and transfer molding? As Farhan already explained, both compression molding and transfer molding are polymer shaping process that use heat and pressure to form thermosetting plastic into desired shape using mold cavity. And in both methods, the material is softened by heat and forced into the shape of the mold, where it's cured, which is hardens to form the final product. We can refer to the picture in the slide as a simple guidance. And the main difference between these two is how the material enter the mold, which is be directly pressed into compression molding or transferred through a channel in transfer molding. Okay, so I will explain how compression molding works. So first, we loading a precise amount of molding compound called it's called the charge into the bottom half of the heated mold, bringing the mold half together to compress the charge and forcing it to flow and conform to the shape of the cavity. Then reheating the charge by means of the hot mold to polymerize and cure the material into a solidified pipe. And next, we open the mold half and removing the part from the cavity. And this combination of heat and pressure maintain the material into the mold until it hardened. into the desired shape and properties. This curing step creates strong chemical bond in thermosetting polymer. Next is how transfer molding works. So first, a pre-measured charge of polymer, usually a solid pellet or powder, is placed into a heated transfer pot, a chamber located above or next to the mold cavity. Then the material is heated in the transfer pot until it becomes soft or semi-fluid but not fully yet pure. And then we plunger or piston then force the softened material through a small passage, uh, or we call it spruce or runner, into the closed mold cavity where it flows evenly and completely fills the shape. Next, we put it inside the heated mold. The material is kept under pressure until it's cured, forming a strong, detailed product with precise dimension. And lastly, once cured, the mold is opened and the finished part is ejected. Any leftover material is transferred. What or screw is removed as waste, or we call it flash. Okay, so I will tell a little bit of benefit of compression and transfer molding. For compression molding, it produces strong and durable part which is suitable for structural application, and also it's low material waste where we use most material. And next, it's suitable for large parts where we can form large and thick component that difficult to produce. And we got good dimensional stability part where the parts maintain their shape and size well after curing. And it's the oldest and cost effective tooling. The mold used are simpler and less expensive compared to the other. For transfer molding, the shape is complex, so we can produce more complex shape because the material flow through the channel, allowing more detail and more design. Then the surface also better finished because the closed mold cavity. So it's reduced wear on the molds. Then also it's less flash and waste because we improve the control over material flow to minimize the excess material. And lastly, it has a good dimensional accuracy. Next. And lastly is the limitation of compression and transfer molding. For compression molding, it's limited to simpler shape because they're complex. We use transfer molding. And then next, it's a longer cycle times. The curing takes more time compared to other molding process. And the flash formation kind of excess material may flow up between mold half and require trimming. Also, it's not suitable for high production rate because it's low. And lastly, its process control sensitivity. It needs a precise control of temperature, pressure, and material charge for consistent quality. For transfer molding, the cost is expensive. The molds and transfer systems, the more complex and expensive other than the other molding. The material waste in spruce and runner also have many because it's remain in the transfer pots and channel after each cycle. It's not ideal for very large parts because the process is better suited for smaller or medium-sized company. Then there is a possibility for a trap air. If not vented properly, the air bubble may form and the product will not be perfect. And lastly, it's limited to thermosetting materials only, thermosets. Yeah, and that's all for compression and transfer molding.
Okay, hello everyone. Assalamualaikum. My name is Muhammad Waisaras bin Muhammad Wadidi and my metric number is 228 106. Okay, so my presentation today is on blow molding, a critical manufacturing process responsible for the vast majority of hollow plastic containers that we use every day. Okay, we will be exploring the how and why this process is so effective for mass production. Okay, next. Okay, what is blow molding? At its core, blow molding is very similar to glass blowing. The process begins with a heated tube of molten plastic, or can also be called as perisson, or a solid plastic preform. This perisson is placed into a custom mold, which then closes around it. Compressed air is injected into the perisson, forcing the soft plastic to expand and conform precisely to the shape of the mold cavity. Once it is cooled and solidified, the mold opens and the final hollow part is ejected. This method is the economical choice for containers where the opening diameter is significantly smaller than the body diameter, enabling very rapid, high volume mass production of parts like bottles, jerrycans, and fuel tanks. Okay, so next. The first main method of blow molding is extrusion blow molding, or can also be called as EBM. In EBM, a plastic extruder continuously feeds a molten tube vertically downwards. The perisson is then indexed into a blow mold, which closes, pinching the bottom and sealing the top near the extruder. Air is then blown in through the top or a blowing pin to inflate the perisson. This process is continuous and ideal for high volume, lower cost items like milk jugs. A crucial engineering consideration here is perisson programming. Since gravity pulls the perisson down, the bottom section tends to be thinner. Machines use special controllers to dynamically adjust the plastic flow to ensure a more uniform wall thickness across the final product. Next. Okay, next we have injection blow molding, or can also be called as IBM. This is a multi-step process, typically in two stages. First stages is the neck finish or threads. It is a precision form via injection molding, creating a stable preform. The preform is then reheated and transferred to the blow mold for inflation. And then next is the most advanced version is the stretch blow molding, or can also be called as SBM. It is used for almost all carbonated drink bottles. In SBM, a rod mechanically stretches the preform before it is blown. This step achieves biaxial orientation of the polymer chains, and it will improve the final products of physical properties like higher strength, better clarity, superior gas barrier properties. This all is very essential for keeping the soda fizzy. This engineering technique elevates the simple process to a high performance material system. Okay, next. Blow molding is versatile, but the choice of plastic is critical. HDPE, or high density polyethylene, is a cheap, chemically resistant, and it is usually used for milk jugs and cleaning supplies. PET, or polyethylene terephthalate, is known for its clarity and superior barrier properties, making it the standard for carbonated drinks due to the strength gained from stretch blowing. Next product is polypropylene, or PP. It is chosen when the container needs to withstand high temperatures, like for hot fill food products. The applications are everywhere, primarily in packaging, but also extending to complex automotive parts like fuel tanks and air ducts. In manufacturing, the material dictates the process and vice versa, ensuring the final product meet its specific functional and cost requirements. Next. From an industrial standpoint, blow molding is highly valued for its high production speed and relatively lower tooling costs compared to the other molding techniques. It is uniquely capable of producing seamless, one-piece parts with features like integrated handles, which saves on secondary assembly steps. However, it also has limitations. It is strictly for hollow objects, and achieving a perfectly uniform wall thickness can be an engineering challenge that requires a precise control over the process variables. The process also generates flash, which is excess plastic that must be trimmed and recycled, adding a small step to the cycle. So that is all from me. I will pass this to the next presenter.
Thank you, Faiz. Brian, can you stop the video? Okay, thank you. So, my name is Muhammad Haziq bin Shaifuddin. My matrix number is 230309. So, today, I will continue by presenting about vacuum forming. So, what difference between vacuum forming and blow forming? That's mentioned by our friend Wais. So, blow forming and vacuum forming work almost the same way. In both is in want to know the difference is the gas pressure. So, they push a flexible sheet so that it shapes into the ball. So, for the vacuum forming, can only use normal air pressure, but for the blow forming, as mentioned by our friend Wais, it's similarly like use the high pressure. Yes. So both the mold and the sheet are heated to the right temperature. So what is vacuum forming? Manufacturing process used to shape heated thermoplastic sheet using air pressure is around 1 MPa. And then um, so wait. So about the process. Farhan, can you play the video for me? So, as you can see on the video, first, the sheet and mold are heated until the sheet becomes soft but not melted. Then, the materials must reach a temperature where it can stretch easily. Gas is blown on top of the sheet. This is this air pressure forces the sheet into the lower mold shape, and then um, at the same time, the gas trap in the lower die chamber is vent out, which is released to the atmosphere. So it doesn't resist the forming pressure. Sometimes a vacuum or slight back pressure is applied to control the process and avoid defect like cavitation, which is like air bubbles. Then we control the pressure rate. The pressure must increase slowly so the material doesn't stretch too fast. And here. Then the sides of the sheet are fixed, so they don't move, and only the center stretch into the mold. The mold has raised border to hold the sheet tight and stop air from leaking out. And then after after the sheet after the sheet cool, the shape is formed, and then keep the pressure until the part cools down and hardens. Then take it out of the mold. So maybe our friend doesn't mention about this. Maybe blow forming is used to make strong and decorative part from metals like titanium and aluminium, especially in planes and cars. So yes, that's all from me. I give to the next presenter.
Hi and Assalamualaikum everyone. My name is Siti Mariam Hidayah binti Muhammad Yusof and my matrix number is 231341. Fahan, can you move to the next slide? Okay, now, that one, the first one. Okay. So now, I'm about to present about composite and ceramic processing. Okay, next. So the first one, we have the composite process. So composite materials are made by combining two or more materials. Composite materials will produce better strength, stiffness, or durability. So we have the three main composite manufacturing processes, which are open molding, closed molding, and cast polymer molding. So one of the advantages and the uses of the composite process are corrosion resistance. Next, it can be molded to complex shapes. Besides, it's also strong but lightweight. Then it's mostly used for structural and lightweight parts. Okay, next. Now, I will be presenting about the open molding composite process. So it has 5 steps. The first one is hand layup. The fibers are placed on a mold and covered with liquid resin by hand. Then the resin is rolled out and left to harden or vacuum back. So hand layup is actually simple and low cost method, but also needs a high skill. It also used for both basic and detailed composite parts. The next step is spray out. The resin then the short fiberglass strands are sprayed onto a mold by using a spray gun. It is fast and cheap, but also gives lower strength and uneven thickness. This is common for large and simple parts like boat hulls, bathtubs, and also tanks. Next is filament winding. The fibers are soaked in resin and wool around a rotating mold. The angle and the direction of the winding are controlled for strength and the shape. It is usually used for pipes, pressure tanks, poles, and also pipe frames. It is strong, but it is expensive and usually automated. The next step is pultrusion. The web fibers are pulled through a heated die to form a fixed shape. It will produce long, strong parts with the same cross-section. It is good for ladders, bridges, and handrails. It is accurate, low cost, and suitable for high volume production. The last step is 3D printing, which can build parts layer by layer using materials like filament or powder. No molds needed, which save material and times. It also allows complex shapes and quick production. The next process is closed molding composite process. It has 7 steps, which is the first one is pre-impregnated fibers, or we call it as pre-preg. So the first one, the fibers like carbon or glass are pre-coated with resin. It will place in a mold then heated and pressed to harden. Then the resin transfer molding, or we call it as RTM. The resin is injected into a closed mold under high pressure. The mold stays clamped until the resin curves. It is great for complex shapes and automotive parts. Next, the vacuum infusion. The dry fibers are placed in a mold and covered with a vacuum bag. The vacuum then pulls the resin through the fibers evenly. It will make large and strong parts like boat hulls and wind blades. The fourth step is compression molding. The fiber and resin are placed into a heated mold and pressed. The resin hardens under pressure. It is fast and clean method for small and detailed parts. Next, injection molding. The heated resin is finally injected into a mold and cooled to form a shape. It will produce a small and high precision parts quickly. Next is autoclave curing. It uses pressurized steam and heat to cure pre-prepped parts in a mold. It will remove air and strengthen the materials. The last step is braiding and weaving. The fibers are braided or woven into strong textile structures. It will create flexible yet tough materials. The last composite process is cast polymer molding. It only has 6 steps, which is the first one is mixing. Resin, catalyst, fillers, and pigments are mixed together to form a thick paste. Then we move to the mold preparation. The mold is then cleaned and coated with a release agent to prevent sticking. Then casting. Mixed materials is finally poured into a mold carefully to avoid air bubbles. Then curing. The mold is left to harden at a room temperature. The chemical reaction turns the liquid mixture into a solid part. Then the fifth step is demolding. Once the mold hardens, the finished part is removed from the mold. The last one is finishing, which is the surface is polished and coated for a smooth and glossy appearance. Okay, next. So the next one is the ceramic process. What is ceramic process? Ceramics are inorganic, non-metallic materials that made by shaping and heating powders. They are hard, brittle, and heat resistant. We have two steps, which is traditional or advanced. So traditional raw materials of ceramics is made by a clay materials that are used to this day to create porcelain, clay bricks, or stoneware. The advanced one usually used in chemical compounds like tungsten carbide and silicon carbide. So this process need to be sorted and stored. It will combine with other ceramic materials to create compound used in the manufacture of goods. The equipments used is like milling machine, storage containers, sintering oven, or casting machine. Okay, next. So the ceramic process have 5 steps, which is milling. Raw materials are cleaned to remove impurities. Then it will prepare for better mixing and shaping. The next step is sizing, batching, and mixing. The materials are refined and measured. It will mix to get a firm and consistent blend. Then, forming. Mixed materials are shaped into the desired form. Common methods are like slip casting, injection molding, and dry pressing. Then, glazing. Dried ceramics are coated with glaze for finish and strength. It is usually done by spraying the glaze on the surface. The last one is firing. It formed and glazed ceramics are heated in a sintering oven, and heat makes them dense, hard, and strong. That's all from me. Thank you.
Okay. And that's the end of our presentation.